differentiation with power rule. So we've seen how to derive a function from first principles, but there's a much quicker way we can do it, and we're going to do this all the time unless we're specifically asked to find it with first principles. So let's learn our rule. So if we have some function y equals x to the power of n, our derivative dy dx, so this is, remember, so important that dy dx is the gradient of the tangent function. What we do is we bring the power down to the front and multiply it by our coefficient. In this case, our coefficient is 1, but we bring down our power. So we get n, x, and we subtract 1 from our power. So let's use that rule. So let's say we've got y equals x squared. Our derivative, we bring the power down to the front and minus 1 from the power, and 2 minus 1 is 1, and we don't have to write the 1 because x means x to the power of 1. So if we have y equals x cubed, dy dx, we bring that power down to the front and we subtract 1 from the power. Y equals x to the power 6, x to the power of 4, dy dx, bring that 4 to the front, and we're going to multiply it by the coefficient because the coefficient of x is not 1 this time, and minus 1 from the power to get 3, and we can simplify this into 24 x cubed. Okay. What about y equals 3x? Let's find our derivative. Well, we bring our power to the front, so that's a 1 times 3 dx. Minus 1 from the power, well, its power is 1. 1 minus 1 is 0. 1 times 3 is 3, and x to the power of 0 is 1. So we end up with 3. And what you'll find is if we have a number or a constant multiplied by our variable, the derivative is just the coefficient of that variable. So if we have y equals 7x, the derivative is just simply 7. So as a general rule, if we have y equals a to the power of x, where a is a constant, our derivative is just going to be a. What about y equals 3? Well, another way to write y equals 3 would be 3x to the power of 0. Just to introduce an x. Now if we find the derivative, we bring the power to the front, so 0 times 3 minus 1 from 0 gives us minus 1, but 0 times anything is 0. So our derivative ends up being 0. And that actually is the case for any constant. The derivative of any constant is actually 0. So we can write this in general expression. So if we have y equals some constant, the derivative is just going to be 0. What about y equals 3x to the power of minus 2? Well, it's no different if we have negative powers. We bring the power to the front, and we minus 1 from the power to give us minus 3. Minus 2 times 3 is minus 6, so we get minus 6x to the power of minus 3. What about y equals root x? Well, another way to write root x is x to the power of a half. And even if the power is a fraction, we can still apply our rule. So our derivative, we bring our power to the front, and minus 1 from the power, and a half minus 1 gives us minus a half, and that ends up being our derivative. Now if we have multiple terms, like 4x cubed minus 3x squared plus 6x minus 8. All we need to do is derive all these separately and combine them together. So for our first term, bring our 3 to the front, minus 1 from the power. The next one, we'll bring our 2 to the front and minus 1 from the power. The derivative of a constant multiplied by x is just the constant, and the derivative of just a constant is 0. So we don't even have to write anything there because we'd just be plussing 0. We can tidy this up. 3 times 4 is 12. So we get 12x squared minus 2 times 3 is 6. So we get 6x plus 6.